Examine whether the following systems of equations are consistent or inconsistent, or if consistent, find the complete solution. Already we have discussed in the 10th standard, which system having the solution, then that is consistent. If the system has a solution, then it is consistent. If the system has no solution, then it is inconsistent. If it has consistent system, then it has two types of the solutions. This is the system of linear equations. The system of linear equations. In these two types of the solutions are there. Consistent means has a solution. Inconsistent means no solution. Has a solution means it has two types of the solutions. One is unique solution. Infinitely many solutions. Unique solution means rank of A, the augmented matrix is equal to rank of A matrix is equal to number of unknowns. Then it is the unique solution. In this, rank of AD, that is augmented matrix AD, and rank of A matrix is less than number of unknowns. Then it has infinitely many solutions. In this, parameters are exist. Parameters are exist. Okay, that is the basic concept of the system of the linear equations. The system of the linear equations means consistent. What is the relation of the consistent? If rank of AD is equal to rank of A, then it has a solution. Inconsistent means rank of augmented matrix AD is not equal to rank of A. This has inconsistent, that it has no solution. If both ranks are not equal, then no solution. If the augmented matrix AD matrix and A matrix, both ranks are same, then it has a solution. When the ranks are same, if it is equal to number of unknowns, unknowns means X, Y, Z, what are the variables are there, those are called as the unknowns. That is equal to the same number. Rank, if it is 3 is there, then the number of unknowns are also 3, then it goes to the unique solution. If the rank is 2, number of unknowns are 3, then it goes to the infinitely many solutions. In the infinitely many solutions means parameters are exist. When we can take the parameters or exist means that parameter is belongs to real number set. The real number set has infinite values. For giving infinite values to this parameter k, we get the infinite many solutions. That is the concept of the system of linear equations. You should remember when it is consistent, when it is inconsistent. Okay. First, I am going to discuss about the problem, how to find out. Here, the equation is, the system of equations are x plus y plus 1 z is equal to 1, 2x plus y plus z equal to 2, x plus 2y plus 2z is equal to 1. First, the given equations can be expressed in the matrix form. The given equations can be expressed in the matrix form Ax equal to D or Ax equal to B. Here, A is the coefficient matrix. X is the variable matrix. D is the constant matrix. Here, x, y, z coefficients. Here, x, y, z. Constant means 1 to 1. Here, x coefficient is 1, 2, 1. Y coefficient 1, 1, 2. Z coefficient 1, 1, 2. Okay. This is the coefficient matrix. What is the coefficient matrix here? 1, 1, 1, 2, 1, 1, 1, 2, 2. It is a coefficient matrix. Variable matrix is x, y, z. The constant matrix is 1, 2, 1. Okay, these are the variable matrix, coefficient matrix, constant matrix. Next, we can consider the augmented matrix. The augmented matrix means the D matrix can be write it as the last column. Add it to A matrix as a last column. Consider the augmented matrix is equal to AD. That is equal to A matrix is 1, 1, 1, 2, 1, 1, 1, 2, 2. It is D matrix is 1, 2, 1. This is it is A matrix, it is the D matrix. Now we can, this AD augmented matrix can be transformed into the upper triangular matrix or using echelon form. That is nothing but we can reduce to upper triangle by the suitable of the elementary transformations of row. Here first we can reduce to these two elements are 0. So R1 row is as it is R1, R2 row is R2. The R1 row is multiply with 2 and subtract from R2, then we get it is 0. Then R3 row is R3 minus R1. Why? Because 1 minus 1 equal to 0. 2 minus 2 means it is R1 is multiple with 2. Just you can check it. The augmented matrix AD is equal to, here R1 is, we can write it as R1, 1, 1, 1, 1. Next R2 is 2, 1, 1, 2 minus 2 into R1 is 1, 1, 1, 1. It is equal to 2 minus 2 is 0, 1 minus 2 is minus 1, 1 minus 2 is minus 1, 2 minus 2 is 0. So it is 0, minus 1, minus 1, 0. Next R3 minus R1 means 1 minus 1 is 0, 2 minus 1 is 1, 2 minus 1 is 1, 1 minus 1 is 0. Next here, this element is reduced to 0. Using of the R2 row only. Why? Because the R2 row has the same first elements are 0. No changing of the first elements. For that, we can operate with R2 only. So R3 row is R3 plus R2. Then 0 plus 0 is 0. So AD augmented matrix is equal to 1, 1, 1, 1, 0, minus 1, minus 1, 0, 0, 0, 0, 0. So here we can take, this is the A matrix, this is D matrix. This is complete zero row. Zero row means the non-zero rows, how many are there? The non-zero rows number, or the number of non-zero rows is equal to 2. So therefore rank of AD is also 2. Next we can take elimination of this. We can take only this is the A matrix. In that also we can take it as how many number of non-zero rows. Only number of non-zero rows are 2 rows are there. So the rank is 2. Here rank of AD is equal to 2 equal to rank of A. Therefore, it has a solution. Then the system of linear, the system is consistent system. It has a solution, then it is a consistent system. It has no solution, then it is inconsistent system. When it is consistent system, how many, which type of the solution is there? Either unique solution or infinitely many solutions. Here, the rank of A is equal to rank of AD is equal to 2. But the number of unknowns, how many are there? The number of unknowns are 3 unknowns. What they are? X comma Y comma Z. The number is 3. Here clearly it has infinitely many solutions. Why? Because row of A is equal to row of AD is equal to 2 less than 3. That is nothing but number of unknowns. So the system is consistent and it has infinitely many solutions. Okay. Now the augmented matrix AD matrix can be expressed in the linear equations. What are the linear equations here? First row is x plus y plus z, the last column as a constant. 0 minus y minus z is equal to 0. No. From this, y is equal to minus z. Y equal to minus z value substitute in above equation. Then x minus z plus z is equal to 1. From this, x equal to 1. The solution is here y equal to minus z means here number of parameters, generally number of parameters are number of unknowns minus rank, that is equal to 3 minus 2 equal to 1. 1 is the parameter. Let z equal to k for all k belongs to capital R. Then y is equal to minus k. Therefore, system x, y, z is equal to 1 minus k, k equal to k into 1 minus 1, 1 is infinite many solutions. But in your standard, up to here only your solution. Therefore, x equal to 1, y equal to minus z is a solution of the given system of linear equations. Here A matrix is 1, 1, 1, 0, minus 1, minus 1, 0, 0, 0. It is x, y, z. The last column as a constant matrix, that is 1, 0, 0. Now we should multiply 1 into x, x, plus 1 into y, y, plus 1 into z, z. So x plus y plus z is equal to 1. The second row is multiplied. It is equal to 1. The second row is multiplied with the column matrix variable. 0 into x is 0. Minus 1 into y is minus 5. Minus 1 into z is minus z is equal to second element of the constant matrix. The third one complete, it's 0. So no need of the third equation. That is the, again we can write into system of the linear equations. From this y is equal to minus z. This value is substitute in above equation. X value is the equal to 1. If x equal to 1, the solution is x equal to 1 and y equal to minus z is the solution of the given system. Here y is depending on z. You can choose z is any value, then you are getting the y is different value. So if z belongs to real number set, means you can choose any one of the value. Real number set has infinite values, so it has infinite solutions.
ఇప్పుడు k ఎందుకు తీసుకు
Here y is depending on z variable. When we can z is equal to k, then y is equal to minus k. Here we can write it as in the variable solution, that is x, y, z. X is 1, y is minus k, z is k. We can take k is common, means here constant. In this first element has no k term. So it is 1, remaining zeros, plus k is taking common, 0, minus 1, 1. Okay. Here k is any real number. K is any real number. You can add these two. 1 plus 0, 0 minus k, 0 plus k. Again you are getting 1 minus k, k only. Here k is the real number set where k belongs to R, but R is equal to open interval minus infinity to plus infinity. It has infinite values. When we can choose any value of the real number set, then we get a solution. If we can take simple, just I am taking the example. Suppose minus 3, minus 4, minus 5, 6, 7, 100. Whatever the value you can take, you get such solutions. That is nothing but k having the infinite values, substitution of the infinite values, we get the infinite solutions. The next problem, the system of linear equation, we can check it. It is a consistent or inconsistent. When it is consistent, either it has solution unique or infinitely. The given system of linear equations can be expressed into matrix form. The equations are x plus y plus z equal to 9, 2x plus 5y plus 7z is equal to 52, 2x plus y minus z equal to 0. The given equations, system of linear equations can be expressed in the matrix form Ax equal to D. That is, A is the coefficient matrix of x, y, z. D is the constant matrix, 9, right side equal to values what are there. We can write those values. Here x coefficient is 1, second equation 2, third equation 2. Y coefficient is 1, second equation 5, third equation coefficient 1. Z is 1, 7, minus 1. where A is equal to coefficient matrix is equal to 1, 1, 1, 2, 5, 7, 2, 1 minus 1. X is variable matrix. It is equal to X, Y, Z, and constant matrix is equal to 9, 52, 0. Consider the augmented matrix. Is equal to AD matrix equal to A matrix is 1, 1, 1, 2, 5, 7, 2, 1 minus 1. Last column as D constant matrix 9, 52, 0. First, we can eliminate, reduce to upper triangular form means we can change into these elements are 0 elements by using of the row elementary operation. Further, R1 is as it is R1, R2 is R2 minus 2R1, R3 into R3 minus 2R1. So, augmented matrix AD is equal to R1 is 1, 1, 1, 9 only. Here, multiply with 2. 2 minus 2 is 0. 5 minus 2 is 3. 7 minus 2 is 5. 52 minus 18. It is equal to 34. Again, 2 minus 2 is 0. 1 minus 2 is minus 1. Minus 1 minus 2 is minus 3. 0 minus 18 is minus 18. Again, it is reduced to 0. So, R3 into 3R3 plus R2. It is multiple with 3. Minus 3 plus 3, it's 0. So, augmented matrix AD is equal to 1, 1, 1, 9, 0, 3, 5, 34, 0, minus 3 plus 3, 0, minus 9, 3 3s are minus 9 plus 4, minus 4, 18 3s are 54, minus 54 plus 30. It is equal to minus 24, 54 minus 34, it's 20, minus 20. Okay. Here clearly, here number of non-zero rows in A equal to, that is, it is eliminated column 1, 2, 3. Non-zero element is there, so it is 3. Number of non-zero rows in AD matrix, it is also 3. Why? Because the last two elements are non-zero elements. So rank of A is equal to 3 equal to rank of AD. And the number of variables, that is unknowns, it is equal to 3. So this is equal to number of unknowns. Therefore, the system is consistent and it has unique solution. Now we can express into linear equations. The augmented matrix AD can be expressed in linear equations. A matrix is 1, 1, 1, 0, 3, 5, 0, 0, minus 4. X is x, y, z. It is equal to 9, 34, minus 20. Write into linear form. X plus y plus z is equal to 9. 3y plus 5z equal to 34. Minus 4z equal to minus 20. 1, 2, 3. Z is equal to minus 20 by minus 4. Minus minus cancel. 4 ones are 4 5s are. It is 5. Z equal to 5 value substitute in equation 2. 3y plus 5 into 5 equal to 34. 3y equal to 34 minus 25. It is equal to 9. Y is equal to 9 by 3 is equal to 3. Y equal to 3. Z equal to 5 and y equal to 3 values substitute in 1. X plus 3 plus 5 is equal to 9. That is x equal to 9 minus 8 equal to 1. From this, x equal to 1 is the value. Therefore, x is equal to x, y, z is equal to 1, 3, 5 is a solution of given system.